Hi friends, in this video we will learn about the operation of N-channel enhancement MOSFET, right? So that is the first thing. Okay, so here what we have to remember is in enhancement mode MOSFET, there is no channel during the initial stage. No channel is present initially. So in D MOSFET, that is depletion MOSFET, channel is available at the initial stage, but in enhancement MOSFET there is no channel. Channel must be created, right? So how it is created, let us see. Okay, so as the name itself is telling, N channel means the channel has electrons as the carrier, right? So electrons are carrier, that is another important point. So substrate is p type. Substrate or body is p type. Okay, these are all the points we have to remember. Okay, so first under zero bias. As usual, what we did in the depletion MOSFET, we classify the operation into 4 different types. One is zero bias condition. Case 1 is zero bias. What is zero bias condition? That is, we assume VGS is equal to 0 volt and VDS is equal to 0 volt. When VGS 0 and VDS 0, what will happen? Let us see. Okay, so here right, so as usual in NMOS we are having p-type body or substrate, p-type substrate. Here 2 n-type regions are created. These are all heavily doped. That side is plus. This terminal I take, that is source. This one it is drain. Next oxide, metal. From there I take gate. So as we know, here you see there is no channel is present initially. No channel. That's why we can call it as EMOS, enhancement MOS, right? Okay. So now let us study. Here you see what is happening. Here VGS 0, VDS 0. There is no potential difference between source and drain, and there is no gate voltage also. So there is no potential difference. There is no voltage. This means no current, no drain current or no gate current. So there is no voltage. So there is no electric field, because we know the relationship between electric field and potential E is equal to minus dLV in point form, or E is equal to V by D. Right? So since V is 0, there is no electric field. So there is no electric field, no current. Which current is due to the electric field? Drift current, that we know. No drift current. So MOSFET is considered to be off. Right? So this is the first condition. Right? So second condition is, what we are doing is VGS still we maintain at 0 volt and VDS is greater than 0. That is VDS is equal. Okay, so before that I have to mention one point. What happens is, so here you see under zero bias condition, we can see that source and drain terminals are separated by the P region. Here you see this is source terminal and this is drain terminal. So these two terminals are separated by P region. So here you see, here we have one P-N plus junction, here we have one P-N plus junction. So this one I can consider as two back-to-back P-N plus P-N plus, right? So here source, here drain terminal, right? So here current is 0, we know that, right? So if we apply enough of VGS, what will be, if we apply VG, what will happen is inversion layer is created. Let us see how it is created, but it will be like this, right? So this is inversion layer. If you apply sufficient amount of gate voltage, we will get inversion layer is created, right? So these are all the things that will happen. Let us see how this will happen. Okay, fine. So case 2, in case 2 what we are going to do, we make VGS till 0 and VDS is greater than 0, that is VDS is positive. So when VDS is positive, let us see what will happen, right? So here, as usual, we will draw it. Okay, this is N plus P type, source, drain, here oxide, metal, right, gate. So again we are applying gate voltage is 0, but VDS is positive. So VDS is positive means source is grounded always. So VDS is positive means this is VDS. This is VDS. Source is grounded, so this I put as 0. Right? So here you see I apply, but there is no potential difference between the, what is the thing? Source and drain, right? So there is no channel formed. Here also I applied some voltage, but no channel formed. No channel is formed for the charge carrier to move from source to drain. So here no channel is formed, right? Okay. So what happens here? No channel is formed. Moreover, we see that here N plus region is connected to P type. So what will happen? The drain and ground, this is reverse bias. So this end is reverse bias, right? So what will happen? There is no current. So ID is equal to 0, right? So this is reverse bias, so drain current is 0. Okay. So that is the second condition. Still we have no current. When VG is equal to 0 volt and VDS is greater than 0, also no current. We will go to third condition. In third case, what we are making is, we will make VGS is less than 0. That is VGS is negative and VDS is as usual positive. Under this condition, let us see what will happen. VGS is negative and VDS is positive. So again, so this is okay. So this is oxide, metal. Here what we are doing, drain, gate. In VGS, negative voltage we are applying, negative. So negative means VGS is gate. So here it is like this we are applying. So here negative charge carriers accumulate, right? So when negative charge carrier is accumulated, what will happen? When there is a charge carrier, it is an insulator. We know electric field is created. The electric field is due to charge carrier. We know static charge. So when electric field is in negative charge carrier, electric field will move towards them, right? Because we know the negative charge carrier electric field lines will be like this. So the electric field will be towards the charge. For positive charge, the electric field will be away from that. That and all we know. So when charges are accumulated here, electric field is due to static charge. These are all static charge. So electric field will be in this direction. Right? So electric field will be in this direction means what? Here we have P-type substrate. What will happen here? The force, what is the relationship between force and electric field? F is equal to Q into E for positive charge. F is equal to minus Q into E for negative charge. So positive charge, force and electric field will be on the same direction. So what will happen? The electric field, this is the electric field direction. So for positive charge, force will also be in this direction. So whatever be the positive charge, the force will act here in this direction. So they will push this force towards the region between the source and drain. So this region will be full of positive charge. For negative charge, force will be opposite. So that means for electron, force will be in this direction. So what will happen? They will push the electron from in this location to away, and some recombination will take place, and all the electrons will go away. Because in here P is a majority carrier. So this area is full of positive charge. So this is called accumulation. Accumulation region. You see, source is N-type, drain is also N-type. In between the two N-type, we are having a channel of positive charge carriers. So what will happen? These electrons cannot flow. So still no current flow. But here positive charge carriers are accumulated, and moreover again you see the source N plus and P, so reverse bias, no current, right? In this way we can explain. So from this what we are understanding, when VGS is less than or equal to 0, right, VGS 0 or less than 0, ID is equal to 0 in enhancement MOS. Still there is no current flow. Right. Now we will come to the case 4. In case 4, what we are making? VGS is positive and VDS is also positive. So under this condition, what will happen? Let us see. So now this is beautiful thing. VDS is positive. Fine. Okay. So here N plus, here N plus, P-type substrate. Now oxide, metal, gate, source and drain. Here what we are doing, we are applying positive VGS. So when we apply positive VGS, what will happen? VGS is positive. So here positive charge carriers accumulate. So we know that this charge carrier creates electric field. These charge carriers cannot penetrate, but electric field can penetrate the insulator because oxide is a insulator. So electric field penetrates, and for positive charge carrier, I know electric field away from that. So electric field will be in this direction. And moreover, positive charge carrier force on the carrier and electric field will also be in the same direction. So what will happen? They will push the positive charge carriers away from this region. So this charge carrier will be pushed away, right? So when it is pushed, what will happen? At the same time, force on the electric field will be opposite to the electric field for negative charge carrier. So here electric field is there, but force will be for negative charge carrier will be in this direction. Force on the electrons will be opposite. So electric field is in this direction, so force will be opposite direction. So this force will push the electrons towards this region, right? So initially when you apply small VGS, right, what will happen when VGS is small, positive? What will happen? These electrons will recombine with the hole, but when you increase VGS, right, some of the electrons breaks that and reaches this region and form channel, right? So at one point of VGS, what will happen? ID starts flow because it will form a channel of negative charge carrier. So ID flows, right? So the value of VGS at which ID flow is called threshold voltage, right? So when VGS is equal to VT, what will happen? Current starts flowing, right? Here you see substrate is p-type, and in that opposite layer is formed. So opposite layer means why it is called, because here majority carrier is holes, here it is electrons. So in the p region one layer of electron is formed. This is called the inversion layer. So the formation of inversion layer occurs when VGS is positive and VDS is positive in the N-channel MOSFET. So the condition is very, very important. So the value of VGS at which initially there won't be any current, right? So when you increase the value and then once your value reaches some point called VT, then only the channel is formed. So when VGS equal to VT, the channel is formed and the current starts flowing. That voltage is called threshold voltage. So it is a voltage. It is a voltage. It is a voltage required. Voltage required to create inversion charge. That's what we are saying. Simply, we can say that it is a gate voltage to turn required gate voltage. It is nothing but gate voltage required to turn on the MOSFET. Required to turn on the MOSFET. That's what we are studying, right? So when VGS reaches VT, then only MOSFET will on, and that is when then only current flows. That is called on state. So before that, MOSFET is off. So these are all the points we have to remember. Okay, so this is very, very important, right? So when VGS is greater than VT, what will happen? When VGS is greater than VT, here you see already it is reverse bias because it is P plus N plus region, right? So it is already reverse bias condition, but when you have a VGS is greater than VT, the electrons will form and the depletion region width will reduce. Initially there will be more depletion region, I told in the case 1 itself, right? So here, where is that? Okay, see, this is the region, right? Inversion layer. Here only the channel will be there, right? So it is full of depletion region. But when you increase VGS, what will happen? This width is reduced and more current will flow, right? So resistance will reduce and more current will flow. So these are all the points we must remember whenever we want to work with NMOS in enhancement mode, right? So normally it is off. When your gate voltage is greater than threshold voltage, then current will flow. So conclusion, what we can conclude, in N-channel enhancement mode, MOSFET VGS is less than or equal to 0, ID equal to 0, whatever be VDS. Whether VDS is 0 or not, or VDS is greater than 0, until VGS is less than or equal to 0, that is negative or 0, there won't be any ID. Second, when VGS is greater than 0, then channel formation starts, right? So that is a point. Okay, so when VGS is equal to VT, ID starts flowing, right? So this is called, here inversion layer is created. Inversion layer, VGS equal to VT and VDS is greater than 0. So when VGS is less than 0 and VDS is greater than 0, accumulation forms, accumulation of charge carrier. So accumulation layer is created but no ID, no drain current, right? So simple, right? So these are all the 4 cases we have to remember whenever we want to work with the enhancement mode MOSFET. Okay, so another thing I want to emphasize here is what will happen if VGS is greater than VT and VDS is greater than 0. What will happen? So when this is the another case, when VGS is greater than VT and VDS is greater than 0, now electron gets attracted towards the positive terminal and current flows. You see, VGS is greater than VT. VGS. This is VGS. When VGS is greater than VT, so what will happen? The electrons get attracted towards the positive terminal. This is the positive terminal. They got attracted towards the positive terminal. So what will happen? Depletion region width reduces near the drain terminal. Right? So here depletion region width reduces. So depletion region width reduces means there will be more current. So that's what happened here. Right? So these are all the points we have to remember. Okay, so next point if you want to remember is at one point here when channel pinch off will occur, that is another important point. So when VDS increases, if you increase VDS beyond certain point, pinch off will occur, that is called VDS SAT. VDS SAT is equal to VGS minus VT. So this is another one important point we must remember in N-channel EMOS. We will learn about this equation in characteristics of NMOS, right? So just you remember now. In the next video, I will explain how it has come about. Thank you.